Hey everyone, we're going to talk about inverse trig functions today. This is a big section. Covers a lot of the things we've already talked about, so you have to be really good at trig to understand this. We've already discussed inverse trig. They basically cancel out the regular trig function. So sine and sine inverse cancel out, or sine and arc sine cancel out. When you see this, sine inverse of 1/2, don't think about sine inverse of 1/2. Think about it the other way. What angle has a sine that is 1/2? So I'm giving you the answer. The answer to the sine question is 1/2. You tell me what angle. Well, there's two answers. On the unit circle, pi over 6 has a sine of 1/2, and 5 pi over 6 has a sine of 1/2. Not to mention the fact that you can wrap around a bunch of times. I could add 2 pi to this. If I add 2 pi to pi over 6, I would have, what is that, 13 pi over 6? That also has a sine of 1/2. So there's lots of answers to this question. By the way, I think we've talked about this, but I'm going to re-emphasize it. Arc sine and sine inverse are the same thing. The reason that I use arc sine is it's easier to type, so that's why. Because we have multiple answers to this problem, we have to restrict the domain. In other words, we have to say we're only looking for the one answer between these two numbers. So for arc sine and arc tangent, we're looking for the answer between negative pi over 2 and positive pi over 2. If the answer is positive, it's going to be between 0 and pi over 2. If the answer is negative, it's going to be between 0 and negative pi over 2. Whereas for arc cosine, we restrict the domain between 0 and pi, because cosine is positive in the first quadrant, but negative in the second quadrant. So let's do the easy ones, sine and cosine. Okay, remember, there are two answers, but we're going to restrict the value. Where on the unit circle is the sine equal to square root of 2 over 2? Well, that's equal at pi over 4 and at 3 pi over 4. Both of those have a sine that's square root of 2 over 2. But wait a minute, it's got to be in the domain. The domain was negative pi over 2 to pi over 2. So which of those two answers is between negative pi over 2 and pi over 2? Just this one. So the answer to this problem is pi over 4. Let's try some. Sine of 1/2. Remember, the domain for sine has to be between negative pi over 2 and pi over 2. The reference angle. What has a sine of 1/2? Pi over 6 does. Is pi over 6 in between these two things? Yes, it is. So the answer is pi over 6. How about a cosine of negative pi over 2? Well, the domain for this thing is between 0 and pi. Between 0 and pi, what angle has a cosine of negative 1/2? Well, I know it's negative, so it's got to be in the second quadrant. And cosine has 1/2 at pi over 3. So it's got to be pi over 3 in the second quadrant. So that's 2 pi over 3. Now let's just make sure, are we in the domain that we wanted? Yes, 2 pi over 3 is between 0 and pi. So the answer is 2 pi over 3. Sine and cosine are the easy ones because you should have those points memorized. Tan inverses are harder. Since tangent is y over x, we'll mentally have to divide each point to see which one works. So, where is tangent equal to square root of 3? Well, I know the domain goes from negative pi over 2 to pi over 2. And I know this is positive, so I'm really only looking between 0 and pi over 2. In other words, I'm looking in the first quadrant. Well, in the first quadrant, I have 3 points that are possible. I have square root of 3 over 2, comma 1/2. I have square root of 2 over 2, comma square root of 2 over 2. And then I have 1/2, comma square root of 3 over 2. Those are the 3 points in the first quadrant. Okay? This is pi over 6. This is pi over 4. This is pi over 3. Now I need to figure out which one, if I divide these two things, will give me square root of 3. And I can eliminate this one, because if I divide those two things, because they're the same, I'll just get 1. So let's take a look at this one. If I did 1/2 y divided by square root of 3 over 2, that would be the same thing as 1/2 times 2 over the square root of 3. The 2's cancel. I get 1 over the square root of 3. But 1 over the square root of 3 I have to rationalize, so I'll multiply by square root of 3, square root of 3. That ends up being square root of 3 over 3. That's not what I was looking for. So pi over 6 isn't the right answer. The answer is going to be pi over 3, so let's prove it. It's square root of 3 over 2 divided by 1/2. That's the same thing as square root of 3 over 2 times 2 over 1. The 2's will cancel, and I get square root of 3. So where in the first quadrant does tangent equal square root of 3? At the point, or at the slope, or the angle, pi over 3. Tangent's pretty tricky. So let's do some easier ones here. For tangent, I know I've got to be between negative pi over 2 and pi over 2. That's the fourth quadrant and the first quadrant. Well, I know the answer is positive, so I know I'm going to be in the first quadrant. Tangent of 1. I'm going to divide one of those 3 points until I get a tangent of 1. But be smart. How do you divide so that you get a tangent of 1? How do you get 1 if you divide? Well, that's when you get the same thing over the same thing. What point in the first quadrant is the same thing over the same thing? Well, that would be square root of 2 over 2, comma, square root of 2 over 2. What angle matches square root of 2 over 2, comma, square root of 2 over 2? Pi over 4. Is pi over 4 in the domain that we wanted in the first quadrant? Yes, it is. So it's the correct answer. How about a tangent of 0? Well, between negative pi over 2 and pi over 2, where do I have a point that when I divide it, I get 0? Well, what's the only way to divide to get 0? You get 0 when you get 0 on top and a number on the bottom. And the only other number that has a point of 0 is 0 and 1. So I'm looking for a point that's the point 1 comma 0. So that y divided by x would be that. So the y value is 0, the x value is 1. I'm sorry. The y value is 0, the x value is 1. What angle matches with the point 1 comma 0? Well, that's the angle of 0. Okay? Because 1 comma 0 is just this point over here. It's still on the x-axis. It hasn't rotated yet. So, is 0 between negative pi over 2 and pi over 2? Sure is. So the answer is 0. Tangent can be tricky. Secant, cosecant, and cotangent are just the reciprocal functions, so we'll flip them first, and then we'll just talk about the sine, cosine, and tangent. The domain of the reciprocal inverse trig function is the same as the original. So, cosecant of negative square root of 2. Before I go any further, I'm going to flip this. This becomes sine inverse of negative 1 over square root of 2. Never leave that like that. Let's rationalize it. If I multiply top and bottom by square root of 2, I'll get sine inverse of negative square root of 2 over 2. What's my domain? I have to be between negative pi over 2 and pi over 2, because that's where sine is. Reference angle. Okay? So, negative square root of 2 as the y value. So what, if I have negative square root of 2 over 2 as the y value, what x value between negative pi over 2 and positive pi over 2 matches this? Well, there's only one of them. Positive square root of 2 over 2. So I want to know what angle makes that point. What angle makes this point? Well, it's going to be pi over 4, but it's going to be in the fourth quadrant. So pi over 4 is one that has the same things. So how do I make it in the fourth quadrant? Instead of going up, I'm going to go down. And that's my answer, which is between these two things. Secant. Your mind will never think in secants. Let's think about it in terms of cosine inverse of. We got lucky. Cosine, if I flip 1, it just stays 1. Cosine has to be between 0 and pi. That's my restricted domain here. I'm looking for some place where the x value is 1. What point has an x value of 1? Oh, 0 does. Okay? What angle is created by the point 1 comma 0? Well, it would be this point right here. What angle is that on the x-axis? It's 0. Is 0 in between 0 and pi inclusive? Sure is. So, there you have it. What about this? Let's just work backwards. What's the cosine of pi over 6? Well, the cosine of pi over 6, hopefully you remember, is square root of 3 over 2. Now sine inverse of that. I want to know what angle has a sine of square root of 3 over 2. Well, what angle does have a sine of square root of 3 over 2? Pi over 3. What about this one? If you're smart, you don't have to do any work. What happens if you do the tan inverse of the tangent? Their inverse operations will cancel out. The answer is 7. Those are the gimme problems on the quiz. What about if it's not something on the unit circle, but something I can draw a triangle out of? For example, this one says, I don't know what the angle is. I don't know what this angle is, but I know its cosine is 4/5. Cosine is adjacent over hypotenuse. I know the adjacent over hypotenuse has to be 4/5 because it's cosine inverse. What's my missing side? You could use Pythagorean theorem. 25 minus 16, take the square root of it, you'll get 3. Now, I got this part taken care of. What's the sine of this angle? Well, sine is opposite over hypotenuse. The angle, the answer is 3/5. Notice I never actually answered the question, what angle is it? I didn't need to. I just had to draw what they gave me. What about sine inverse of x with a cosine on the outside? Work backwards. So I'm going to draw a triangle. Here's my angle. Sine is opposite over hypotenuse. But x isn't a fraction. It isn't something over something. Yes, it is. It's x over 1. So the sine is opposite over hypotenuse. X over 1. How do I figure out what this is? I'll use Pythagorean theorem. It's this squared minus this squared. Take the square root. Now let's find the cosine of this angle. How do I find cosine? Cosine is adjacent over hypotenuse. What angle, or what side is adjacent to that angle? Square root of 1 minus x squared over, what's the hypotenuse? 1. Because I don't need to divide by 1. Dividing by 1 doesn't change the problem. That's my answer. Inverse trig is very hard. It's hard because you learn it one way and then we ask you to do it backwards. Remember how hard subtraction was when you first learned it in kindergarten or in elementary school? Remember how hard division was when you first learned it in elementary school? Remember how hard square roots were when you first learned them? Remember how hard logs were when you first learned them? Those are all inverse operations of a function that you already know. Inverse trig functions take some time and you have to think about them a lot. You might even have to draw out things like I just did. But if you practice them enough, you will get them.